Right. Power all good? Already? Is that okay in terms of volume? I'm not like shouting too loudly. Is that okay? Is it good? Okay, great. All right. Welcome, welcome, welcome. Take a seat, grab a beer, wine, soft drink. Huh? A few seats at the front here, Patrick. Patrick. Come on, don't be shy. So, welcome everyone. I can't believe it's been 2 years. 2 years we've been doing this. Usually every last Thursday of the month, but we had to configure the dates because we're doing our second Internet of Things meetup in Glasgow tomorrow, but we'll be resuming normal schedules as from next month. Will be the final Thursday of the month, the Internet of Things Edinburgh meetup. And I think we're going to do Glasgow every other last Wednesday. We'll see about that. We're just testing a new venue over there, and we're building a new community and so on and so forth. So thank you so much for coming along today. We've got 3 fantastic speakers. I'd also like to give the floor to our sponsor, because without sponsorship support we can't do this for free. Huh? Oh, what happened? Did it go into sleep mode? So, echo, 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 echo. Would you like to say a few words? And then we'll do like an open forum where you guys can stand up and talk about your projects or some IoT events or whatever, you know, community news type thing, and then we'll continue with our first speaker.
Thanks, Simon. So I'm Rebecca Hastings. I'm the manager for Spring Technology in Edinburgh and Glasgow. So Spring is an IT and digital recruitment business. So feel free to get in touch with myself or anyone else if you want to find out a bit about the careers that are available within the Internet of Things market or any other areas in Scotland. So I hope you have a really good time tonight and enjoy the speakers, and pizzas have been ordered, so feel free to enjoy them. Thanks.
Thank you. Always good to have some money in the room. Very kind, honestly. So kind of you, because we like pizza. So, is there anyone who'd like to stand up, introduce yourself? Do you have an announcement? Go ahead. Oh, hold on a second.
Thank you. So the first announcement is that if you are not aware, the British Computer Society BCS is organizing monthly talks. Next week is this month's talk. It's on IT and health, so everyone is welcome. It's on Eventbrite and on the BCS website. The second announcement is that I recently found out that our proposal on the SigFox challenge for counting people at historic site progressed to the exploration stage, and I would like to acknowledge this Meetup and Product Forge in helping to develop the idea and giving some ideas about the implementation.
Great. Anyone else? Anyone else? Jack? No, Patrick. Grab the microphone. Another microphone.
Hi, I'm Pat Hickey. I'm based up at Summerhall. The company's called Nifty Technologies. I was just going to, it's not really an announcement, but I just want to share my sort of last month's work. I've been cooking Raspberry Pis, so building Raspberry Pi computers, but I discovered a great bit of software called RetroPie, which is a games emulator system which can run all platform games. So if anyone is interested in kind of retro gaming and computing, drop me an email and I'm happy to share some of the materials that I've got. Give you an SD card. If you bring your SD card, I can put some software on for you. So thanks.
Very good. Anyone else? Okay, cool. Thanks for that. So, SigFox. Raise your hand if you've heard of SigFox. That's pretty impressive, actually. For those of you guys who Don't worry, I'm not going to do the whole sales pitch, I promise. But you know, things, connected objects, they need connectivity, right? And quite often they're not within the range of a Wi-Fi connection or a 4G connection. So how do you solve that problem? Low power wide area networks. And everyone talks a lot about LoRa, you know, the LoRa network, which is a kind of an open standard. And these guys are doing amazing things. I think you closed the largest VC round in French history. Does that still stand? At the time it was. I don't know if BlaBlaCar, they did a pretty big round. Yeah. So anyhow, a lot of innovation, and I'm sure Nicolas will explain how SigFox differs from Ingenu and NB IoT and all the other low power wide area networks. But connectivity is kind of the glue that will power the next machine to machine you know, network. What I like to call, and increasingly others are calling, Web 3.0, the third iteration of the internet. And yeah, without connectivity, all these connected objects are not going to be able to speak to each other. So let's move on to our next speaker. You've got everything set up and configured, and you're good to go. Fantastic. Round of applause to Nicolas from SigFox. Do you want to...
Thanks a lot. Okay, good. Yeah, so Simon had the easy question, so I can see that almost half, or maybe even more than half of the room know about SigFox, but how many of you understood who we are and what we are doing? Yeah, okay, I can see a little less hands, so maybe I'm not doing my job good enough. To introduce me quickly, so I'm at SigFox since a little more than 2 years. My job is to drive the adoption of the SigFox technology, SigFox service, all from a technology point of view. So I won't be able to deliver you a sales pitch today. It will be more technical focused, but trying not to get too deep into details towards everybody. I think we'll have time for Q&A either at the end of the presentation or later on around some pizza and beers. So feel free to ask anything afterwards if you need details. You've got my contact information, anything needed here. So to say it briefly, SigFox is a communication service. It's a technology, a radio protocol and so on, used for this communication service. We are not pushing down a technology for you to integrate and do whatever. It's a service that we offer, is ready to use in production right now in a little bit more than 30 countries. So mostly Europe, South America, Asia, Africa, getting there and so on. I will detail you what low energy and simplicity means in our own context. Those are the main focus of the technology and the service. So all the choices, the design choices, the architecture choices have been more towards energy efficiency, simplicity and so on, to make sure that everything, not even connected objects, but anything, any dumb thing around us is able to send some small but important information around for very little energy cost. Because in the end, energy is a lot of money, and it's pretty easy to have projects that just don't fly because you spend way too much energy to send useless data. Okay, let's get into some details. So this is what SigFox looks like. Basically, you have a bunch of devices doing what they need to do, waiting for an event to happen, or measuring some environment value every 15 minutes, every hour, every day, depending on the use case. So it could be, is my water tank is full, empty, half empty, and so on. It could be an event, if the door being open, if the temperature above the security level, magnetic field, whatever. A lot of use cases I could detail afterwards. So all your objects will send their data, depending on the use case, and messages are picked up by your own network. So when I said we are not pushing down the technology for you to integrate, it means that it's not up to you to set up these receiving stations, to deploy on your own private site, or to build different networks that will compete against each other. You will have in each country exclusive operator, which is in charge of building up the infrastructure, So in the UK now, it's WND who is taking charge, taking the lead after Arqiva, which was in charge over the last few years. So setting up base stations around, waiting for signals to come in. And then through our own cloud, depending on your own configuration, we push the data down to your own application server up the way you like it. And you can, of course, go both ways. So up, what we call uplink communication, so up from the device to your own application server, or down from your own application server to the devices. So it's small messages, no security camera broadcasting over SigFox. Please don't try that. It's about a few bytes of data, up to 12 bytes, 140 times a day. So it's not about opening a data socket which stays open to exchange data back and forth. It's really for sensor information, very small information every now and then. So this is where the service is available right now. So of course, it's pretty convenient for us to paint the whole countries in purple, but you also have what not everybody is doing. You have online the detailed production coverage. So all the purple countries are being under-allowed. You can guess that for Australia, Brazil, or the US, we are first focusing on the, let's say, useful areas where you have population, where you have business. So right now, Australia, for example, almost all of the population is covered, but a very tiny fraction of the desert is covered. I have a zoom on Europe. So this in blue is the live service which is available right now in Europe. It's one network. I was speaking earlier about operators, but it doesn't matter for you as an end user. A device that communicates here in Scotland can move to Paris, where I came from earlier today, and works exactly the same. No other contract issues, no roaming questions, and so on. It just works. From Portugal to Denmark, through the UK, Germany, Italy, whatever, you can either ship your solutions across the world to your different customers, or if you have moving solutions, let's say asset tracking, you want to monitor deliveries, shipments, pallets, whatever, it can move all around and keeps working exactly the same, seamlessly. And I zoomed over the UK, and picture is cropped, unfortunately, but you can see that UK is not yet as well covered as other countries in Europe, but it's moving forward, especially for Scotland right now. You only have coverage around the Glasgow and Edinburgh areas, and if I speak fast enough, I may have time to show you that it really works today. So this is I'll try to get fast on that, but try to focusing. IoT means a lot of things. It can mean bullshit a lot of the time. What we are focusing on and what we are good at are industrial application, bits what you can call industry 4.0, predictive maintenance, and so on, agriculture, security, asset tracking. So not the fancy gadgets that you'll buy on the online shop that you wish, or that you will back on Kickstarter, but mostly industrial application, business applications. So not the sexy, fancy devices, but the applications that quickly add values, improve businesses, make some money, which is usually pretty good. So it's this part of the iceberg, the one that nobody wants to see, that nobody will want to hear about your IoT business, because you are tracking waste containers, you are monitoring railway tracks, that kind of stuff. But it's useful, and it's the real IoT today. That's where things are happening right now. Most of the few millions of devices that are on our network right now are here. You will have some B2C solutions, of course, but that's not the volume. The volume is here on the B2B or B2B2C or whatever you want to call it. So to detail a little more the technology, so the protocol which is underlying the SigFox network, key parameters is, it's as simple as it gets. You have no connection per se. You have no negotiation with the cell tower. You don't have to ask the network when you can communicate, on which frequency, which channel, that kind of thing. It's really the other way around. The network is not disciplining the devices, but the network is here to serve the devices. So the device is the master of every communication, which means that you just power on your device, it sends its data, and the job of the network is to be ready to pick it up. There is no synchronization beforehand. All of that is made to optimize energy consumption, because it takes way less time on the air for the device for a successful communication, less energy consumption, longer battery life, lower total cost, and so on and so on. So no signalization channel, no pairing with the cell, no handover, nothing like that. Just broadcast your message and let the base station do the heavy lifting. So to throw some numbers, when we say low energy, depending on the chipset that you will be using, you can use chipset from various partners, from ST, Microchip, formerly Atmel, ON, a smaller one like module makers that you have all around the place. You can check them online. Consumption will vary a little, but you will stay in the tens of milliamps during the few seconds of emission. So between 15 milliamps and 50 milliamps in Europe, roughly, depending on the solutions. So this is during the 5-6 seconds of emission. The key factor is that 99.9% or even more of the time, your device is just doing nothing. It's not connected to the internet with an IP connection, something like that. So you don't do anything, so you don't burn energy. That's what allows devices in production to have battery life of 5-7 years, depending on the solutions. Communicating close to nothing, a few microamps, even down to 800-900 nanoamps on the latest solutions. So you get long range of communication between a few kilometers when you are in urban context, difficult propagation and so on, to tens of kilometers in the countryside when you have flat countries and so on, and up to the horizon, or even more than that when you have very favorable conditions. The current record that we have is from a tracking company. Is doing some GPS trackers and using them on boats. That the message is sent from islands, from the southern coast of Ireland, that have been picked up on the northern coast of Spain. But that's not what will happen on a daily basis. It's just what happens when everything fits well. But we don't overpromise. But when we say that you'll get reception to 30, 50 kilometers in the countryside, that's a reality. That's not just a marketing claim or some bullshit. That's something that you can just check right now for yourself in production. So yeah, I was saying early on, small messages. So I didn't forget any units. I come from a web background myself, so I was used before SigFox in sending megabytes of useless data, JSON, XML, name it. Here it's down to mostly computing like in the 80s, getting down to binary stuff, using as little energy as possible to describe, as little memory as possible to describe your data. Because again, the smaller the message that you send, the smaller the time that you will spend on the air, and the smaller amount of energy you will consume, the longer the battery life, and the less energy the less maintenance costs in the long run, and so on. We are using very slow data rate because we have a very small power output at 25 milliwatts in Europe, and to get tens of kilometers of range, we cannot do that on a high data rate. So in Europe, it's 100 bits per second. So every byte that you send or you don't send has an impact on the communication time. So hopefully I will be able to show you what it looks like live. This is the radio spectrum of one of our base stations in production. So right now, so we are using what we call unlicensed bands, which means that we don't have to pay billions of fees to use dedicated radio bands like 3G, 4G, for example. But it's shared spectrum, meaning that everybody is allowed to use those radio frequencies, so 868 megahertz for us, for free. Be it us, be it other radio solutions, be it scientific application, medical applications even, radio amateurs, whatever. So you've got a lot of what we call undesired signals. So all of that is activity which is not proper to SigFox, but that our stations have to cope with. And this is a SigFox messages, like small spikes in the spectrum on only 100 hertz wide. So there is no channel per se. So within these 200 kilohertz part of the spectrum that our stations are monitoring all of the time, you can have close to 2,000 possible frequencies at the same time. So this allows for high capacity without synchronization, because each device will send its message on a pseudo-random frequency within this range with 2 repetitions, which help the stations detecting them, collaborate between the stations, and offering a guaranteed service level without any pre-synchronization mechanism in place, and so on. This is what makes the offer quite unique, is the ability to guarantee service on unlicensed bands, so with a very low cost of operations, and without useless synchronization or communication going back and forth and tampering your battery in the end. Hardware solution, I'm sorry, I'm going quite fast through it because I really want to make room for a demo without eating the time of the other speakers. So hardware solutions, I don't know if a lot of you are into hardware. Yeah, so basically you can use either off-the-shelf modules. So our module is the radio part, the MCU, all in the box, ready to use how you wish. Put it on your PCB, plug an antenna, and let the magic happen. It should be okay. So modules right now, you can get them starting at $2, even lower than that, without MOQ, with an MOQ of 1. Or you can even build your own solutions. You can do your own solution using your own transceiver, your own MCU, because maybe you have a legacy device that you want to upgrade, or you want to retrofit whatever solutions you already have in the field, or you have very custom needs. This will cost you a little more time and energy because you will have to integrate a own binary, going through certification and so on. But to make it short, right now, starting from $2, you can get a functional module available and get started in a few weeks. Either from major companies like I mentioned, or smaller module makers like Wisol, Inocom, Telecom Design, Telit, and so on, or all the big names that have radio compatible solutions available from TI, ST, NXP, on Semtech, even if they don't like a lot to talk about that. They've got a chipset which is perfectly compatible, and modules are coming along the way. It's expanding a lot, but your provider of choice most probably already have a SigFox ready solution available for you without you doing all the work again and again and again. So service means it's not only about the hardware. So this is nice, but the offer that we have is that we also receive your data, process them, and give them out to you. So either you want to just have a look at the online portal to make sure that your first Hello World has been received. This is what I will show you afterwards. You can synchronize your applications, your database, your proprietary applications, whatever, using a REST API. So it's all standard stuff. But the mechanism that we recommend is what we call callbacks. So other companies would call that webhooks, whatever. It's a push mechanism, meaning whenever one of your sensors in the field out from the 1,000 that you have will send a message, we will forward this message alongside some metadata, so who the device is, when the device was sent, where was it received roughly, and push it down to your own application, but push it down your way, meaning that you don't have to do custom developments to ingest the SigFox data, but tell us what you want to receive, CSV, XML, your proprietary format, and we will push it down to you. And within a couple of seconds, your device will have sent a message, you will have received it, and you're able to do whatever you want. Trigger an alarm, place a phone call, just update your database, alert your customer, send back some data to your sensor because maybe you want to shut down the water valve because you received a leakage alarm, and so on. Yeah, so that was the callback slides. So thank you for listening to me. I know my English is far from perfect, and I'm often speaking too fast. You got plenty of links with details. I'm available to give you some more info, and I will try to do a demo. It worked before, I promise, and usually when I do them on stage, it fails. So please be nice. Basically, the point is trying to show you that it really works. So what I will try to use first is just a USB dongle. So a USB dongle with a SigFox module in it, and send a message with it. Okay. Okay, hopefully you're able to see something. Okay, so basically I just connect to the USB dongle and I can send him IT commands. So for those of you who worked with old modems or some cellular stuff and so on, it's pretty standard. So a set of attention commands to just send your instruction to the module for it to send the message. So it's ready. And if I want to send a SigFox message, it's as simple as saying, okay, attention, send frame. And I've got then up to 12 bytes. So in hexadecimal, meaning I can send 0A, 1, 2, 3, 4, cafe, because I'm quite tired at the end of the day. And now it's sending the message over the network. And here it is. I don't think you can see anything. Okay, I'm sorry, I never remember how to zoom. Okay, this one was pretty easy. Okay, so this device, I know him because I tested earlier, is called 1D28 unique ID on the network. It doesn't have an ID address or a MAC address, it's a SigFox ID. So this one is pretty small because it's a very old device. I think it's something from 2012. Back when we started. So I've got some information about it. I'm on the SigFox portal. And when I check its message, okay, I don't know if you can see it. Yeah. So you can see that we received at 8 p.m. This is French time. It's not being sent in the future. I didn't fake it. So it should be 7:11 here. So we received 0A 1234 cafe. It has been received by 2 stations with a received signal strength intensity of -132, -117. For those who are into it, sensitivity of the base station can get as low as -142 dBm. So this one is pretty good. -117 means that we have a station that's probably pretty close. So some details about the detailed frequency and so on. Don't get too excited. You don't have access to this detailed information when you're a basic customer. I've got it about the detailed frequency, but all you care as a user is that the message has been picked up. How it has been picked up, it's our job. My job is to explain you that it's not just magic and to show you how it works. And using the API, I can even ask where it has been received. So it's not this one. So I thought it was 1D2A. Okay, so this message has been picked up by 2 stations in Edinburgh. So I'm not very familiar with the place, but basically you should be more than me. So there is one which is near the golf club in the west. I don't know how far it is. And what's interesting is that you can see this is only a demo device that I use from time to time. So previous test was when I arrived, just to make sure that it works. But before that, I used it in Germany. It was not received in Berlin and Munich at the same time. There's a station that was not located properly in the system. But it worked in Germany, it worked in England, and before that, most probably in France. So the same device with the one contract can move around and just works and is received exactly the same way. You don't have to bother with complicated stuff and so on. It just works. You already have a lot of work in IoT in finding something relevant to say from your device. It's really a hard job. The job of how to say it, how to transmit the data, we do it. Focus on finding something to do, finding something to say, and do something with the data. There already a lot of hard work on both ends. not to be bothered by losing time on the communication part. That's why I try to insist on the simplicity part of the solution, is that you can guess that something like that, it won't be really hard for one of your developer to come out with that and being able to extract, let's say in this context, 0A means a lot. In a few days, you will have a proof of concept that sends this data over SigFox to your application servers, and for you to try to do some graphs, exploit the logs, and so on. So focus on where you have added value, and don't lose time and money on parts that are secondary to your business priorities. Speaking about money, we are nice guys, but of course we are not doing that for free. So the whole business model is not on selling out the chipsets. We don't get 1 cent from ST or from Microchip when you buy out solutions. Where we get our money from is from subscriptions. And subscription price ranges roughly, depending on your volumes and so on, but it ranges from €1 a month per device to €1 a year per device. That's it. So I'm not good at currency conversion versus the pound. It should be a little less than that. But very small subscription cost. And the whole point for us is for you to do millions of them. Of course, this works only with the high volume that we all expect from the IoT that are getting there. We are still speaking about millions of devices today. Everybody likes to play with the analysts who speak about billions. The billions are not there yet, but we can see ramping up over the last 18 months. The volumes are starting to really ramp up, and that's where our business model makes sense. That's it. So I'm pretty happy that my demo worked, so I won't risk a second one. But basically, this is it. It just send something, receive it on the other end, and do something with the data. And you can, in the same way I sent a message, I can ask the network, do you have an update for me? Which will tell me, switch your operational mode, switch the frequency of measurement, shut down an equipment because something is faulty or because the customer is not paying anymore, whatever is relevant for you. We don't deal about the complexity of your use case. We're here to help you build it up, but we're just here to take the data that you extract from your environment, from your own use case, and transport it to the other end. So basically, this is it for me. I don't know if we have time for Q&A right now, or if I already spoke too much.
So I think what we'll do is like a really quick Q&A, and then we'll take a break, and Andy can get set up. Because what I like to do is do a panel Q&A at the end with all the speakers in front of the room, and our third speaker actually will be joining us via Skype. If you have a question.
Thanks, Ta. So in a typical tracking device, you would need a GPS receiver, which obviously eclipses the power consumption of your device. Can you triangulate with your device?
The answer is it depends. As usual, when we try to be honest. So either you want a precision by the meter or by 10 meters, and today nothing beats the GPS for that. So you will need an extra GPS, the extra consumption cost. So be wise in the way you use it. Things are starting to show up with the clever tricks, by offloading the processing to the cloud and so on. But either you need a GPS to keep it simple, or maybe you will do indoor location. This way, maybe switch to a Wi-Fi based geolocation. Just grab up the Wi-Fi hotspot around you, send them over SigFox, and match them up against a database, either the one from here from Google, and get your location. Or you can use network-based location. So in this case, no GPS, no extra radio, but it won't get as precise as GPS. We don't do triangulation. Basically, it's a probabilistic model based on the reception patterns. So in my example, my device has been received by those two stations. So I know it has been received by 1C E4 at -132 and 0B7 at -117. So most probably, given our simulations and the backlogs that we have with the field test, we are able to give you out a pretty accurate location, but not by the street. what you will get is something like that. So, I'm sorry, the zoom doesn't work pretty well. Basically, that's a test I did earlier on. So it was telling me I was here, which is not that good because I'm here, if I'm good. But in fact, it tells me I'm here with a pretty wide confidence radius. We know at 99% that we are here. So if you're looking
So bad if you lost your cat.
to recover a stolen dog, it's not good enough. But if you are tracking your fleet of trucks, it's way enough. You don't need the extra cost of the GPS in this case, because all you need to know is my truck near my storage point A, my storage point B, my customer 1, my customer 2? Is it in Edinburgh, in London, in Glasgow, in Dublin? In this case, it's way enough. The whole point is, what data do you really need? In some cases, you really need a GPS. In some cases, knowing that you are downtown Edinburgh is way enough. It's always a balance about what you want and what you can afford. There's no silver bullet.
Yeah, thanks. You can send 140 messages a day per connected independent device. How frequently can you send a message from a device? Can you do all 140 messages in 1 hour and then wait 23 hours before you can send again?
Two answers to that. You can send more than that. You can then send them in a row, but you are not allowed to do so. This limit is here per the European regulation. As I said, we are using unlicensed bands, shared spectrum, and the regulation in Europe for everybody using this band, not only us.
Yep.
Maybe we are the only ones speaking that much about this regulation, but 1% you are allowed to use for free this band 1% of the time each hour, which means in SigFox term roughly 6 messages per hour.
Okay.
That's why we rounded it down to 140 per day as a contract. So if you send 200 a day on a regular basis, we'll have an issue with you in a customer relationship about abusing the contract. But most importantly, if you communicate more than 1% of the time on a regular basis in production, the issue won't be with us. The issue will be with the regulation authorities.
Okay, but if I was sending a message which was just 1 byte rather than the full 12 bytes,
so
could I not send more messages?
Not more than 140 because that's the contract. We don't sell by the byte. We sell by messages. But regulation-wise, yes. If you send empty messages, that's what some customers do because the message itself is the message.
Yeah.
We don't fill up the frames with zeros. So instead of having 12 bytes of useful payload plus or headers, you will have only the headers or the headers plus the 2 bytes of your frame. So instead of having 6 messages per hour, you can get up to 8 or even 9.
Okay.
While sticking into the regulation. So this is very important, not for testing. I do more than that. I abuse the regulation every time I'm doing demos. But when you project into production, it's important to have those regulations in mind, because if you get caught,
yep,
or if you have a nice competitor whispering your name, you will have bad issues.
Yeah. So I mean, we're under the same rules in terms of the duty cycle being 1%, but we don't have the same restriction in terms of the number of messages. As long as we obey the duty cycle, that's the key point. You have to obey the duty cycle, so that ultimately constrains how many messages rather than it being a fixed thing. And so the variation in the length of message that we send, if we send short messages, that means we've got more messages that we can send over a set period of time because our on-the-air time is less for each message that we send.
So you can send more.
Yeah.
You have the contract-wise number and you have the duration one.
Yeah. Okay,
so
promise.
As long as you respect the duty cycle,
yeah,
it can be 6, 7, 8, up to 9, depending on the
very
weight
quick last question, because it's about differences between different technologies. There's no default encryption that you put into the network. You have to roll that yourself, do you?
Yeah, by default, the frame itself is not encrypted.
Okay.
You've got encryption mechanism that help giving a secured signature. So you've got by default anti-spoofing, anti-replace, anti-man in the middles attacks. We offer solutions off the shelf, be it ST as secure elements. So you can do encryption. You got a default offer for encryption if you want. You can build your own. either with hardware components, if you can afford, or just software-based. There are different approaches. Again, there is no one-size-fits-all in encryption or security. It's a balance between the how critical is your data? Is it just the temperature of your potato garden, or is it a critical information? And what you can afford in terms of extra hardware cost, extra consumption cost, and so on. Usually what we do is that we do recommendations about what is the most proper solution to use in a given use case. And it's up to us, the customer, to use the more relevant one in its own use case.
Okay, I think you guys should probably take it offline and have a chat, because Nicolas has come all the way from Paris, is that right?
Yeah.
Today. So, it's a great opportunity for you guys to actually, extract as much information while Nicolas is here. So I think we're going to end it there. Round of applause.
Thanks a lot.
Thank you so much. We're going to take a break, and I promise you, the next speaker, Andy, undersea subs and swarm technology, is really, it's a very exciting project. So I promise you, it's worth staying for. So do we have some pizzas arriving, or? Okay, well, we'll probably do the pizza break if the pizzas arrive. If not, we'll just sort of get cracking on with the next one. But either way, Andy, come to the front, get set up, and you guys take a quick break. Well, like a 5-minute break, maybe. Okay. You see what I'm concerned about? This pizza's going to arrive and everyone's going to make a dash for the back of the room. Okay, guys, I think we're going to get started. Otherwise, we're going to start falling behind schedule. And we've got a third speaker in London who is waiting for us. So take a seat. I promise you will not be disappointed. It's going to be the best talk you have ever witnessed in your entire life. Okay, maybe I'm exaggerating. It's pretty darn good. Okay, Richard at the back, don't trip over that. I already did that 3 times. Call health and safety immediately. All right, Patrick. Gordon, are you okay? You can hear us in the back? Everyone. So when the pizzas arrive, I don't know what we're going to do, though. Do we just ignore them until Andy's talk is over, or do we sort of put Andy's talk on hold? I'm not quite sure. Oh, okay, the pizzas have arrived. Get going. Grab pizza. Grab pizza. Pizza has to take priority, and then we'll get stuck into the next talk. Okay, guys. All right, let's get started. We've got 2 more speakers. Grab a slice of pizza, grab another beer, grab another glass of rosé, or cup in this case. Grab a seat. Okay, guys, ready. Simon at the back. Who have we got? Where's Richard? Tim, Ian. Okay. Gordon, Richard. Okay. Rebecca. Actually, I'd like to plug. I wasn't going to do this, but I've decided to do it. So a little initiative, and I will be quick, I promise. Just a secret initiative that Andy knows about. Okay, so don't tell anyone. So I'm forming a consortium of companies based in Edinburgh, and it's called DX3. That's the name of the consortium. Jack, Andy, you guys already know about this. It's invite only, and we're specifically targeting startups that are working in the area of decentralized machine intelligence, so machine-to-machine communications. So if you're in that area of machine-to-machine communication, machine vision, but it's got to be machine-to-machine. So autonomous drones, all that sort of stuff. We're focusing on solving problems around industrial sectors and enterprise, not really interested in kind of consumer and smart home stuff. So see me afterwards if you're interested in joining this consortium, because I'm seeing too many amazing, talented startups that are not getting any traction because they're either individuals or they're small teams, and we need to start grouping together and working as a sort of a machine entity ourselves. So Gordon, you're working on an interesting project, aren't you, to do with drones? But we'll come to that later. So have a chat with me afterwards. So Andy, are you good to go? What you need to do, is just minimize that. Let's get that. And we need to maximize your pitch deck. There we are. Play. You've got the widget. There you are. There you go.
Right, yeah.
All right, over to you. Round of applause, please.
Okay, thanks everybody for coming along tonight, listen to my presentation, and thanks to Simon for inviting me along. And I'd like to tell you about my company PicSea and a little bit about possible development of Internet of Things at sea. So we're going to talk about me and what I'm all about, and how the Internet of Things can be applied to the ocean, communications at sea and under the sea and how that works, and how you navigate in the sea, how PicSea is different from anything else that's available at the moment, our plan, and hopefully how you guys can get involved. So this is me doing the stupid picture. I'm an underwater robotics engineer. I've got an MSc in computer vision and robotics. I worked for the last 5 years at the University of Sydney, developing, deploying, maintaining underwater vehicles, and collecting the data and distributing it to clients. I'm now working full-time on my PicSea project. So Internet of Things, Simon said, hey, do you want to do a presentation at Internet of Things Scotland? And I was like, oh great, what's that? That's like we have a fridge, right? And then it orders your shopping automatically. And I was like, so I went home and I went into Wikipedia, and I was like, okay, Internet of Things, and how am I going to, stick this together with my robotics at the sea? So I took this picture from Wikipedia site, as all great researchers do, and it's all fitness and intelligent homes and security and all those sort of things. But just one thing about them, they're all based on the land. There you go. Did I miss a slide there? No, that's right. Okay, so communications at sea. Is there a slide missing there? No, okay, we'll keep going. Yeah. Okay. So it's gonna check it's the right file. Anyway, communications. let's see, it's a very difficult thing. You need
The latest one that you sent me. Are you worried it's the wrong day?
yeah. I'll keep going anyway.
Do you want me to find the other one that you sent me?
No, is this the one from today?
Yeah.
Yeah. Okay. All right. Okay. Sorry, guys. Yeah. So underwater, it's very difficult to talk to anything because basically the only option you have to do long distance communications is to do acoustic communications. Over very short distances underwater, you can do optical communications, which you can get relatively high speeds. But yes, over very short distances, like about 10 meters, you'd be lucky to get that. So traditionally what you do when you collect data from especially underneath the sea is you put something in the water, a sensor, a robot, some other vehicle, and you bring the device up and you bring it onto the boat, then you plug it in, then load it onto a hard drive, you take the boat to the port, then you plug that into your computer at home or in your office, and then you get it onto the internet. So with intelligent devices, we're looking at in the sea, we're talking about getting rid of the boats and talking about getting rid of people involved. So what are your other options? So you can send data by radio satellites, by radio to satellites or to land. You can have cables. On the seafloor, and then you can get that cabled up to the land, but it's very expensive, and obviously your sensors are only then in one place. Navigation is another issue at sea because as soon as you go under the water, you don't have any GPS anymore. So, what do you have to do? And it's no good getting data out of the sea if you don't know where you got it from, because it's completely useless. So, when you go to the water, what have you got? You've got a compass, gyroscopes. This is a special kind of sensor called a Doppler velocity log. This you can use to, it's basically a giant 3D optical mouse that works with acoustics. So as you move along, it gives you X, Y, Z displacements, and you can integrate this into a bigger model. And the same for an accelerometer, you get the same sort of data and you integrate it over time. Problem with these is all the errors grow exponentially with time, and you become uncertain of your position. Depth is very easy because you just measure the pressure, and you know when it's this pressure at a certain depth, you have to account for tides, but it's relatively easy. And also we have visual odometry, so we take a series of images. If you have cameras that can see anything, once you're close to the bottom, and you can use this to build into your model, stick it into a Cohen filter, and get an accurate navigation solution. This is the wrong set of slides. I have on a stick, I think.
For USB stick. Shove it in.
Okay, well, in embarrassing failure, but we're back in, I think. So we got, so we had a few, yeah. So it's going to be a bit messed up, but here we go. So what, So which data do we want to get from the seas? Geophysical, so sonar, this is what you use to build up the kind of maps that we have, pretty much of all of the ocean. Visual imaging, which is very difficult to get because you have to go to the bottom of the sea. You have a very small viewpoint, and it's you need a lot of images to do this. You can do coring samples, so where you physically send down an apple corer, take an apple and have a core end of the apple of the bottom of the sea, and then have a look what's in that and infer some geotechnical information about that. Or you can do seismic surveying. So you create some impulse often from an explosion, and then you listen to the sound that comes back, and from this you can then reconstruct the shape of what's in the bottom of the sea and also subsurface. Environmental data, that's where I operate traditionally when I worked in the University of Sydney, and looking for things like temperature, turbidity, how difficult it is to see through the ocean, and from this you can apply biological aspects like how healthy is the ocean, and by analysing chemicals in the sea, what if there's any pollution, and how likely is it things are like to survive, and the way they interact with each other. Acoustic data is a particularly interesting one for Internet of Things. So there's a lot of this kind of thing set up where you have just a bunch of microphones or hydrophones in the sea, and they listen in networks, and from this you can see where marine mammals are, and also detect like seismic activity from tectonic plates moving and things like that. Who wants to see ocean data? So explorers, I think it's normally said that we know more about the surface of the moon than we know about the bottom of the sea. So there's a huge amount of stuff to be explored there. Prospectors, so anybody who wants to exploit a resource from the sea, whether it be oil, fishing, and mining. So subsea mining's coming into the domain now. And if you want to do that, you also need resource management. So monitoring the environmental effects of an oil company, like making fisheries work properly, ensuring that they're not getting overfished, and that the environment that the fish have to breed in are appropriately managed. Science, I mean, there's all sorts of science in the sea, but if you've ever been on a marine research vessel, you always go and find something that nobody's ever found before. Infrastructure inspections, that's becoming more and more important with infrastructure like offshore wind coming into play. Pipelines, they all need periodic inspection along with cables into the sea, and if you don't, then you got chances of not detecting something that could cause like a pipe rupture or data loss over an international cable. And defense, there's a lot of people that are trying to hide things in the sea, and there's a lot of people that are trying to see what people are trying to hide in the sea. So obviously that's a very interesting thing. It's me doing a bit of a survey there. There's some scallop beds. That was a project I worked on. That was pretty cool. That's methane cathrate. That's the methane deposits that you can mine and turn into fuel. And that's a pipeline inspection. So it's got my pirate ship this time on this version of the slides, but so I think we've covered that already. And navigation instruments. And yeah. And so I start to talk about PicSea now. Sorry for running late, I got a bit confused there. So yeah, we're working on developing a low-cost autonomous underwater vehicle, a robot you can put in the sea that is used to build up 3D maps of the bottom of the sea. And this is very expensive at the moment, so what I want to do is move the worlds of the oceans to like the few organizations that can afford to commission this data at great expense to the many that need and want to explore it and analyze that data. And yeah, just explore, manage, protect the resources that are there, and just generally gain the knowledge that can be accessed. So how are we different? Yeah, so it's tackling the two main problems of collecting this sort of data: low cost, or completely changes the way